This lecture is an overview of how to interpolate contours. It's more the theory behind how contours are interpolated and plotted. Again, the theme with my coursework is that instead of learning which button to push or which subroutine and menu to pull down, which changes from manufacturer to manufacturer and version to version, is to understand what's going on when you mash those buttons so that you can troubleshoot if something turns out not to look right or be right, and also so that you know how to troubleshoot to know when something doesn't look right. This is a very simplified example. There's one brake line, not too many points. This is similar to what we'll do in the labs and what your assignment will look like. So, first thing is that raw points are plotted with elevations. This can be done by CAD, by software, or it can be done by hand. If you don't have access to or want to figure out how to use software, depending on your circumstance, just like we have computed coordinates from our simple traverse, we will be able to, and we'll compute coordinates from our topographic survey in the final lab. So here, 6 points have been plotted, 36, 38, 41, 42. These points are just more or less roughly a 50-foot grid shot. In here we have top of bank, TB, and TB, and then bottom of bank, BB, BB. So this is where a cut slope has been graded with equipment, so it's a brake line. So we get the points plotted, decide what we've got. Next we'll decide where our interpolation lines are. And 38 to 41 is a brake line, 49 to 40 is a brake line, so we definitely want to start with those, and we'll connect the other dots. And then within this box of 36, 38, 41, 42, 36, we don't have a triangle, and we need to form a triangle that's reasonable, and we want to use the shortest distance. So we've connected 38 and 42. 36 to 41 is longer. And you can tell that by scaling or by computing if you have things in your software. So we're just generating data. This is the next process, is to determine where those interpolation lines are. Next we'll add the distances. They don't have to be plotted on the worksheet. I plotted them, and this is all CAD generated. But I plotted them to illustrate where you could see the relative distances. So this is 52 feet over here, 48 feet over there, 56 across the back. This is roughly what I would see with in gentle to rolling terrain. We might try to roughly take a 50-foot grid informally with brake lines, which is the most common approach for collecting topographic data, as has been discussed. So now we're just adding another piece of the puzzle, but now we have everything that we need. We have the elevations, we have the distances between them, we have the interpolation lines set up. So I want to discuss this to illustrate it. The graph format is the more time-consuming, but the easiest way to discuss it. So we're looking here at 42 to 41. And there are two sets of points interpolated. I'll draw the line to divide them. And 42 and 41 are right in here. And so if you look at it, 42 is at elevation 104, which I have brought over to my graph. And then we're interpolating down to number 41, which is at elevation 96, which we've added right here. So you just kind of have to visualize we're going from 100 down to 96. What contours are involved in this leg of interpolating? Well, if we're going from 100 to 96 on 2-foot contours, you've got 100, 98, and 96. And here's where the theory of interpolating applies to developing contours. So we know that we're starting off at elevation 100.4. So how do we determine where between 42 and 41 the 100 contour will cross? Well, we first set up that the total difference in elevation is 4.4 feet. We are going the proportional distance from 42 to 41 of 0.4 of 4.4. So 0.4 divided by 4.4, that is the proportion of this line that we're going down to see where the 100-foot contour intersects. The reason for that is we start at 100.4. The difference in elevation to the first contour line is basically the difference in that elevation to the next contour line. So that's 100.4 down to 100. So that's where this 0.4 comes from. The total difference in elevation that we will achieve between 42 and 41 is 4.4. Now the distance between them is 52.25. So, and this is all set up from one point. You have to think about one point is your host point. That's where everything's measured from. The other point is just there to provide data. So from 42 to 41, the 100-foot contour is going to cross at 0.4 divided by 4.4 times the total distance of the line between 42 and 41, which is 52.25 feet. You do the math, 0.4 divided by 4.4 times 52.25 gives you 4.75 feet. So with an engineer's scale and paper or in CAD, you come 4.75 feet from 42 down to this point right here towards 41, and that's where the 100 contour crosses. Similarly, what is the difference in elevation from the host point, 42, down to the next contour line? Well, it's just 2 feet more than the first one because we're now going 100.4 to 98. So you subtract 98 from 100.4, that's 2.4 divided by 4.4 times 52.25 gives us a new distance of 28.25 feet. And that's where this tick mark comes from. So what I'm doing here is I'm plotting tick marks where my interpolation comes out. Now, it's obvious that 96, a point with elevation 96 is where the 96 contour is going to cross. But just to show how the math works up, it's the full 4.4 divided by 4.4, or 1.0 times 52.25, which is 52.25. So, we got another, basically a tick mark here on top of number 41. So that's where, look at the 96 is right here. This is the 98. And then this is the 100 where it's crossing. Now we're looking at 41 to 38. We're looking at a new different line. We're looking at this line right here. 41 is elevation 96. 38 is elevation 98.7. So we're still graphing. Our host point is down here. We're coming uphill now to 38 because 38 is higher. So our little graph is accurate. We're going up from 96.0 up to 98.7, which is the elevation for 38. And then we have the 96. So we're going from 96 to 98.7. Which contours are involved? The 96 we've already established. That's going to be just on top of 41. And then the only other contour that crosses between 96 and 98.7 is 98. So we're going up in elevation 2. So our 98 interpolated point is 2 feet divided by the total difference in elevation, which is 2.7 feet of the distance between between 41 and 38, which is 45.7. And you do the math, that's 33.85. That gives us this purple tick mark right here. Well, now it's a purple tick mark. So here, and again, that's the 98. So to do that legibly, but so we can already tell that the 98 is probably going to cross. It's going to be connected something like that. So another way to look at it is a chart. And obviously you could set up spreadsheets, and obviously there are very simple software programs and algorithms. But if we look at, say, the graph from 36 to 38, 36 is here at 102.5, 38 is at 98.7, so we're going to be crossing with the 102 and the 100. So we're starting off at 102.5, we're 0.5 of 3.8 times 4781 gives us 6.29 feet out from 36 to the tick mark where the 102 contour will cross. Well, if you want to look at that in graph form, we say the set 36 to 38, writing the elevation down to keep us straight, 102.5 and 98.7. The next contour from 36 is the 102. It's 0.5 of the total times the distance, 6.29. Same thing right here. Likewise, the 100 is 2.5. Don't have to repeat all this. It remains the same unless you change it. So 2.5 divided by 3.8 times 47.81 is 31.5. So you come, if you want to look at it up here, say I'll go to blue, you come 31.45 out. And on the line horizontally between 36 and 38, that's where the 100 contour will cross. So here's some more chart interpolating, and this is all in your handout. But this is all we're doing is looking at from 38 to 39, for example. This is where we get into this cut slope. The top elevation is 98.7. We've got that here. We're going down to elevation of 94. That's from here to here, from 38 to 39. So from 38 going towards 39, that's 98.7. Going towards 94, the first contour we'll get, or the next contour, is the 98. We're coming from 98.7, so the difference in elevation to our first contour is 0.7. Divided by our total difference in elevation of 4.7, multiply times 23.91 equals 3.49. So that's where this first tick mark is for the 98 contour. Then we're going to say, the 96, it's 2.7 feet. In the difference in elevation to the next contour from the host point, 38. Multiply that time, divide by 4.7 to see the portion of the total, multiply times the distance of 23.41 gives us 13.45, which is this second tick mark. And it goes without saying that this point is at 94, so the 94 contour is here. So once we've gone around, and you can see here I've developed tick marks all the way around all the sides of this six-sided figure. And now the contours come to life. All we do is just simply connect them. You can label each tick mark if you'd like, or you can keep track of it. You can look at it each time, like I'm looking at, starting here at 42, I'm at 100.4, going to 102.5, so I know I'm only crossing the 102. And then I'm going from 98.7 to 102.5, so now I'm going to be crossing the 100 and then the 102, so that's 2 points on the 102. I'm going to connect them. That's the blue line. And then here from 42 to 38, the diagonal, I'm going from 100.4 down to 98.7, so I'm really only crossing the 100. That's what, we'll make, say, that green tick mark. Coming down 42 to 41, same thing. The next contour we come to is the 100. And you want to look at 36 to 38 again. We're coming down on the 102 and then the 100. So we connect those dots. This is the 100 contour line. You just basically rinse and repeat. That's the 100. This would be the 98. The 96 would start at the 96 contour, run over to here. 94 runs to the interpolated point between 41 and 40 up to number 39. And then we finish up with this little short 92 contour down here. So that's all just from connecting the tick marks, keeping track of which tick mark goes with which contour. Notice that below this big break line, 38 to 41, the contours get steeper. So that's point 38 and point 41 were observed in the field as, okay, we need to get these locations, even though we're not 50 feet. We need to get the top of this break line. We need to get this break line at the top of this slope, and we need to get the bottom of this slope, which is another break line. All this is work material. Your final product, minus border and notes, is going to look like this. Now, index contours, the 100 in this case, are usually the only ones actually labeled, but I've labeled all of them for illustration. So we're coming up the hill kind of steep, and then it's not just going up and leveling out. Our cut slope is intersecting ground that slopes a little bit differently, and we come up, the 98, the 100, the 102, and so forth. So that, in a nutshell, in 15 or 16 minutes, is the theory behind how contours are interpolated from grid, approximate grid and break line topographic approach. Thank you.